Hi everybody. So let's multiply and divide radicals that have negatives in them. In other words, complex numbers, if you will. More on that in a minute. So let's take a look at the square root of negative 8 divided by the square root of 2. There's a couple ways to do this. You could rationalize the denominator if you want. I don't think that's the easiest thing to do in this case. What I'll do instead is use the quotient rule for radicals, where I can make one big radical and go the square root of negative 8 over 2. That's the same thing as the square root of negative 4, which will be 2i. The I coming from the negative there, right? And of course, the square root of 4 is 2. So that one's done. Now, before I launch into this next one, let me show you what the definition of a complex number is. Okay, that's a plus or minus bi, where the first part is the real part, and then the second part is the imaginary part. Okay, and that's what we're seeing here. We got the real part is 6, and the imaginary part is the negative 2y. Down here, the real part is 3, the imaginary part is negative 4i, the real part here is 6, the imaginary part is I. You get the idea, right? Alright, so let's distribute your negative 2i to this complex number, 6 minus 2i. So it's a distributive property just like you've been doing. So it shouldn't be anything different until we get to the end part, okay? So negative 2i times 6 is negative 12i. Negative 2i times negative 2i is a positive 4i squared. But remember, this is where normally we'd be done at this point, right? But this is where we're going to be taking additional steps now. I squared is a negative 1. So really, this is going to be 4 times a negative 1 on this term here. So now we're looking at negative 12i minus 4, which then becomes, I want to write this with the real part first, then the imaginary part. So negative 4 minus 12i. That's the answer there. So let's look at a binomial times binomial type situation now. 3 minus 4i times 6 plus I. So first outer centers last is kind of the mindset we want to go with. 3 times 6 is 18. 3 times I is 3i. Negative 4i times 6 is a negative 24i. And then negative 4i times I is a negative 4i squared. Combining like terms, 18 minus 21i minus 4i squared. Normally we'd be done at this point, right? If it was just like x instead of I. But remember, I squared is a negative 1, so I got extra steps now. 18 minus 21i minus 4 times a negative 1. So that's 18 minus 21i plus 4. Now the 18 and the 4, they're going to add together. That's going to be 22 minus 21i. So that takes care of that guy. Now let's do this guy in orange. 1 minus 2i quantity squared. Now be careful, don't just distribute that 2 through and call it done. What we're really seeing here is 1 minus 2i times 1 minus 2i. I'm going to have to erase a bunch of the board here so I can have room to work this. Okay, so first outer centers last. 1 times 1 is 1. 1 times negative 2i is a negative 2i. Negative 2i times 1 is a negative 2i again. Negative 2i times a negative 2i is a positive 4i squared. Combine like terms, we've got 1 minus 4i. And then over here, remember, I squared is a negative 1, so this is really going to be a minus 4, right? I did skip a step or two this time. So that gives me 1 minus 4, which is negative 3, minus the 4i. Alright, so that's how you would multiply and divide, if you have a monomial type situation in the denominator, complex numbers. More on dividing complex numbers in my next video.